Thank you for joining us today for Semiconductor Insight's teardown of the Nintendo Wii. My name is Greg Quirk, and I'm the Technical Marketing Manager at SI. With me is Alan Yogasingham, SI's parts researcher.
The Wii is Nintendo's entry into the next generation of video game consoles to compete with the Xbox 360 and Sony PlayStation 3. While Microsoft and Sony tout details on their high-end graphics and processing engines, Nintendo has been more focused on gameplay, claiming the Wii allows for everyone, from young to old, a new interactive experience in gaming. Greg, we had a chance to play with the Wii before we started taking it apart. What were your thoughts?
There was actually a demo disc of sports games to get familiar with the system and the new motion sensing controller. It was quite intuitive to use and surprisingly responsive. We played a few innings of baseball and pulled off a few KOs in boxing. As you can see here, Sam, one of SI's lab technicians, is taking apart the Wii console. There are a number of screws, including some that are hidden.
Compared to the PlayStation 3, the Nintendo Wii was a lot easier to take apart. Watch as Sam removes the outer casing. Here Sam removes the front of the casing to show the optical drive. Here Sam removes the screws to take apart the Wii at its seams.
We can see here the board from the optical drive. The interesting component on the board itself is the Elpida 16 megabits of SD-RAM.
Here we have Sam removing the metal casing to reveal the motherboard of the Wii. Broadcom was involved in the development of the Wii. During this teardown, SI discovered two components. One was in the controller and is the wireless Bluetooth chip. The second chip is the BCM4318, the latest in their line of Air Force One single-chip 802.11b transceivers. This was found on a secondary board shown here. This chip enables the integration of Wi-Fi functionality in the Nintendo Wii. Through this, you can play games with others online and download games developed for Nintendo's older systems.
ATI provides the graphics processing with the Hollywood chip. SI suspects that the Hollywood uses NEC's 90nm embedded DRAM. The IBM Broadway processor controls the Nintendo Wii. The Broadway is designed using a 90nm process lithography and a silicon-on-insulator process. IBM also made the processor for Nintendo's last console, the GameCube. Beside the Broadway part, we can see Qimonda's 512 megabit GDDR3. This is one of the first times we've seen Qimonda-marked devices, as Qimonda used to be part of Infineon. On the back side of the board, we can see Samsung's 4GB 65nm NAND flash. This is the same memory device that SI analyzed back in June. Now that we've taken a look inside the console, let's take a look at the motion-sensitive controller. With the 3-axis motion signal processing technology, the controller recognizes actions performed, mimicking them in the game. There are a few components of interest in the controller. Analog devices and STMicroelectronics were the key suppliers for the sensors in the controller.
So after taking a look at the insides of the Wii, I have to say that it's a lot more fun when it's put together. Compared to the PlayStation 3 that SI took apart previously, the Wii is considerably less complicated.
I hear you, Alan, but it's the gameplay of the Wii that will set it apart from its competitors. Thank you for joining us for Semiconductor Insight's teardown of the Nintendo Wii. If you have any questions, please visit our website at www.semiconductor.com.
Done, mother.